seeing the beginning of time. We have probably all dreamed of this, and researchers have now found out how it works. In other words, how we can see all the way back to the beginning of the cosmos and the creation of time itself. Stay tuned to go on a journey through space and time with me, and if you like it, I'm galactically happy about a thumbs up and a comment, because that's how we get the YouTube algorithm to show this video to even more people. Thank you guys and welcome. It is not too little time that we have, but too much time that we do not use, said the ancient philosopher Seneca. And one thing is clear, time is the rarest resource in the universe. No matter how rich you are, you can't buy much more time. And even if we humans eventually overcome our mortality through technology, that doesn't change the fact that time is still limited, because at some point even the universe dies. So it's no wonder that we are so fascinated by time, and that's why physicists have long been searching for an explanation of what time is. But it's not that easy to say. So before we go any further, let's play a little game. Write in the comments how you would define time. What is time? I'm really looking forward to your attempts, and we'll take the time to answer as much as possible, I promise. Basically, time can simply be seen as a causal chain that describes the sequence of events. If I push a domino, this leads to a causal chain reaction. And the totality of the individual causal effects could be described as time. But don't get too excited, people. It's not that simple, as we've known since Einstein. In the special theory of relativity, time is regarded as part of a four-dimensional spacetime continuum that can deform and is influenced by gravity. You know it from movies like Interstellar. Gravity, in this case from a massive black hole, not only affects space, it also warps time and also causes what is colloquially known as time travel. If you spend 5 minutes next to a black hole like Gargantua from Interstellar and then come back to Earth, where time has been less strongly influenced by gravity, you will realize that many years have passed. So if time is part of the four-dimensional space-time continuum, then it does exist somehow, doesn't it? And is not just a sequence of a causal chain? But if time really exists in its own right, where is it? Like everything else, it would have to be anchored somehow at a subatomic level. Everything in this room here can be traced back to the smallest structures at quantum level. You are just a special arrangement of quarks. You are, of course, the most beautiful collection of quarks I have ever seen. But a subatomic particle of time doesn't seem to exist. At least we haven't discovered it yet. We can measure time with great precision, but there is also no evidence, for example, that it works differently at the subatomic level than in the macrocosm. Most theories about the nature of time are based on mathematical models and observations in the macrocosm. But they have not yet been confirmed at such an atomic level. So all in all, we can say, time is obviously there somehow, looking at my gray hairs. But we have no idea what it really is. Even though it plays such an important role in the cosmos. After all cosmological developments take place on a time scale. The Big Bang, for example, which according to the prevailing opinion created the universe in the first place, happened at a certain point in time around 13.8 billion years ago. If this was the beginning of space, it must also have been the beginning of space-time. And how fascinating would it be if we could look back to that point? Some of you smart Alex will object.
Every look into space is a look back in time.
Yes, that's true. Our eyes are basically time machines. We see things as they looked when the light was on its way. The galaxy was 2.5 million light years away, so we see it as it looked 2.5 million years ago. We see the sun as it looked just 8 minutes ago, and so on and so forth. But unfortunately, the very early part of space is hidden from our view. It was only when the cosmos cooled down sufficiently, almost 380,000 years after the Big Bang, that electrons and atomic nuclei were able to combine to form complete atoms. At that moment, light was no longer absorbed, but was able to fly unhindered through the now electrically neutral matter. In other words, the cosmos became transparent. And up to this point, we can look back and see a gigantic, all-encompassing wall, the cosmic background radiation. It is not possible to look behind it, at least not in the optical range. So we have to trick our way around it somehow, and that's where some scientists come in, who say we can look back to the beginning of time itself. Dr. Deepan Garg, who is involved, says, we can't see the early universe directly, but maybe we can see it indirectly by looking at how gravitational waves from that time affected matter and radiation. Gravitational waves are disturbances in spacetime caused by the gravitational pull of celestial bodies. The heavier the objects, the more pronounced the distortions in spacetime. For example, when black holes or neutron stars, i.e. incredibly dense objects, collide, spacetime begins to shake to a noticeable extent. And clever scientists on Earth can measure this with very expensive instruments. And the researchers' idea is as follows. What if we trace back the gravitational waves of the very early cosmos and thereby glean information about the beginning of everything? The Big Bang was obviously an event that released an enormous amount of energy and must have caused spacetime to vibrate. However, the Big Bang was a few days ago, and that makes it somewhat difficult to detect the very, very early gravitation. Our technology is currently still limited to detecting gravitational waves in the area of the collision of stellar masses, black holes, and neutron stars. No sign of primordial Big Bang gravitational waves. But the researchers have now developed a revolutionary method for this in the context of plasma physics. Nothing to do with donating blood plasma, which is how I used to earn a lot of money as a poor student. As the temperature rises, substances usually change successively from a solid to a liquid and then to a gas. If the temperature is increased even further, a plasma is formed, which is why this is also called the fourth state of matter. And the researchers have now used the propagation of electromagnetic waves through plasma as a simulation for gravitational waves in the universe and set up a series of equations that describe what to look for when gravitational waves travel through stars and gas in the depths of space. Or as Deep and Garp puts it, we basically applied the plasma wave machinery to a gravitational wave problem. This is an ingenious way of using terrestrial research methods to find out more about the elusive cosmic phenomenon of gravity. And the researchers have indeed been able to make a very interesting discovery. The propagation of gravitational waves through matter produces a detectable signal, for example changes in the light produced by stars or huge gas clouds in the spaces between the stars. These signals can reveal gravitational waves that are currently beyond our ability to detect. For example, the ominous Big Bang gravitational waves from the beginning of time. With this method, we have the key to an indirect look back in time to the Big Bang. And I can already see your doubting looks, but we can read all sorts of things from gravitational waves. Since gravitational waves are generated by the acceleration of masses, they can give us information about the movement of matter and radiation in the early universe. For example, how did the elements form? How did the first stars and the first galaxies form? They can also tell us how the expansion of the universe has changed over time, ending an eternal argument about the Hubble constant, i.e. the rate at which the cosmos is growing. And primordial gravitational waves can also help us better understand the nature of dark energy and dark matter, which together make up around 95% of the energy in the universe, and of which we still have next to no clue. So, it seems that there are invisible timestamps of the time after the Big Bang scattered all over the cosmos, which we could read out with the new method inspired by plasma physics and thus obtain answers to the biggest questions of all. Let someone else say science isn't exciting, so the researchers have discovered that these weak gravitational waves produce a signal that we can read. Now someone just has to do it so that we can really get a glimpse of the beginning of time. Speaking of time, since the beginning of this video, you have raced several thousand kilometers through the galaxy, no joke. The movement of our solar system is quite different from what you think. And you can see the incredible, true movement in the video below, so be sure to take a look. And if you want to support my work, then have a browse through my space store. There you'll find the shirts from the videos, real meteorites, plush planets, and much more. Every purchase helps me to keep the channel going. Otherwise, I'd say see you in the next video. Take care, guys.